Hello there. We are going to do the most important activity with Xsemble, namely the design. As you understand, design is a software development lifecycle phase and it comes just before the development. The purpose of design is to plan out how the software is going to be structured, what happens after what, and how the code is structured and all that. You may be used to seeing UML design. Here we are going to do the design using Xsemble. But the advantage of doing it with Xsemble is that this design is going to stay with you for life. As you fix bugs in the software, as you enhance the software, you keep coming back to the design, you plan the changes based on the design, make those design changes, then that percolates to the further uh, uh, code development and so on and so forth. So basically this design is going to be an accurate representation and up-to-date representation of what is happening within the software. That way it has got immense value for visibility into what's going on. So let us begin the journey together. I have Assembler's Workbench and Developer's Workbench open. These two applications are going to be used within the design process. So to start with, let me create an Xsemble project. New project, and it says what is the workspace I want. I can always choose a workspace that I already have, but instead of that I'm going to create a new workspace called tasks. Why did I create a new workspace? Because a workspace is going to be my top level container which is going to contain my projects and repositories. In fact, the workspace also becomes a folder on the file system within which the projects and repositories can reside. So whenever you are starting a new software development, new client or something like that, you create a new workspace and keep stuff within that, and you will be able to check those into one Git repository or some other configuration management tool that you have. Great. So let's call it a main project. If the project is large, then we would want to uh, break that into several sub projects and all. But for now, let's call it main. A personal task manager. This is going to be a simple task management system. Let's now go over the layers. You can see that couple of layers are already created for me, and if I go to the templates, then depending on the kind of application that I want to make, I'll be able to choose one of the templates. So which application do I want to make? I can make a command line application, I can make desktop application, I can create web applications with Java, I can create a web application with PHP, I can create a Python based web application, I can create a command line application with Python. But for now I'm going to stick with Java web application using the Jakarta E technology. So once I click OK, the layers corresponding to that technology will be chosen over here. If I chose something else, then obviously the layers will change. You can see the Python layers being chosen here, but let me come back to the Jakarta E ones. Then comes the repository dependencies. You can see that x.core is already put for me here, and that is pretty helpful, pretty thoughtful of Xsemble, because x.core is something that contains the simple basic components, the basic types like integer, string, list, set, date, etc. So I'm going to need that anyways, so I'm going to leave it as it is and click OK, so that the new project is created for me. You can see on this tab the name is task.main. So this project is created. The task is the name of the workspace and the main is the project name as we gave. I'm already given a start node within the project. It is like a flowchart. You start with the start node and then it is going to traverse across various nodes after that. So what do I want to see? The first thing, this being a personal application, personal task management application, there is no need for a login screen or something like that. The first screen that we are going to look at is the list of tasks. So when we say screen, then we need a UI component. For that, let me create a page instance. I get the new page instance node. I'm going to name it as task list. Then there is a page/implementation. This is the underlying component for the task list. Now, do I already have an underlying component here? No, I'm going to make one. So let me create one here. It says, do you already have a component and implementation? I say no. so that it will create a dummy component for me on the backside. This is a pattern that you will see repeated across Xsemble, that you will have the instance node in the X flowchart, and then there will be a component somewhere that powers it. The component will go in, the component will contain the code and all the other functionalities. So you can create any number of nodes in the same X flowchart or in different X flowcharts, so that the same component code will be reused across all these nodes. So far so good. I'm just going to click OK, so that this task list node is created. Okay, I'm just going to show it here. I can modify it. Now let's try creating a link between the two. Try creating a connection. What happens after what, right? So always remember in Xsemble, when you're connecting two execution nodes, then the node where the connection originates from, and that is where you will start doing the connection. So in this case, I'm going to draw a link from start to task list. So let me start with the start node and click connect. And what am I going to connect? I can connect either the exit or the out data. In this case, I'm talking about the control connection, in the sense, where does it go after the start node. So I'm going to use the exit, and I'm going to select task list in this. Right now there are no other nodes, so anyway task list is the one, and the link is created, isn't it? So it's not the other way around. So fine, we understood how to create the link, but is this link correct? This task list is going to show me the list of tasks. Where is it going to get this list of tasks? We haven't loaded that list of tasks yet. So basically the task list should have the list of tasks, and we need someone else to load that list of tasks, maybe from a database or maybe from some Excel sheet or whatever that is containing those tasks for us. Okay, so that component which does all the work is called a method instance or a method node. Let us create a method node for creating the task list. So this is load tasks. Again, do I have a method component? No. So I'm going to create one here, and I'm going to place it right here in between them. Now let me do the connection again. Now I'm going to use load tasks to connect that, and from load task I'm going to connect the exit to task list. Now this is correct. Now let's worry about the data. This load task is going to load that task list, right? Now the data is being shown here. It says a new data node, and that is the task list type. Now I can use an existing type called lists, which is available from x.core. So this is just a list of tasks. If I wanted a specific type for task list, I can do that, but for now I'm just preferring to choose this generic list type, which is good for me. Click OK, so that node is created. Now from load task, this will be the output, and for task list, this is going to be the input. So this data node is not an execution node. Anytime there is a link between an execution node and non-execution node, the execution node is going to be the owner. So this load task is going to say that, hey, I want to output data to this guy. Similarly, task list is going to say that I want to take the input data from here. You cannot do it from the task list data node itself. Let's make it happen. From load task connect out data to task list. What is the argument name? I'm creating a new one. It says task list. That is good enough. Connect in data, again task list. Create new is fine. The name should be task list. I'm good with that. So this is the way we have just created our first set of control connections, which are the gray colored arrows, and first set of data connections, which is the dashed blue colored arrows. So let's now worry about what happens after the task list. So from the task list, I certainly need to add a task to the task list. How do I do that? I may have a link or a button called add task on the task list page. So what happens after that? Now let us quickly understand the concept of layers. And for that I'm going to revisit these nodes. Start, look at this layer, it is under the Jakarta E layer. Then load task, it's also under the Jakarta E layer. For task list, it is going from the Jakarta E layer, it gets originated on the Jakarta E layer, but then there is an arrow which goes to the web layer. So basically the output side of this task list is in the web layer. Okay, so now from the web layer, how is it going to connect to something on the server side? The next functionality is going to happen on the server side. So anytime there is a page that takes you to the web layer, you will need to come back to the server side, and for that you will need a special type of node which is called an entry point node. So let us create that entry point node here. This is an entry point instance. It says add task entry. Do I have a component? No. And for an entry point you always need to give an URI. So it is customary, it's conventional to use /x with respect to links in Xsemble, but it is not at all a mandatory thing. So I'm going to say add task. So this entry point is created. Now this task list will be able to connect to this add task entry. Let us do that. Connect the exit to add task entry. Should I make it next is fine for now, but if I want, I can go and change the name of the argument. Instead of next, suppose I want to call it something else, say add task, then it's a better idea, right? It's more descriptive. So now I have renamed it as add task. After add task, of course there should be something to actually add the task. So I'll need to see another page which will help me take the parameters of the task. So let me create that page, add task. I'm going to create this page later. For now I don't have one, and I created this. Let me connect this exit to add task. Connect. Now from add task I'll need, again this page is also taking me to the web layer, so which means that I'll need to add an entry point to come back to the server layer. New task entry. Okay, URI, say save task, or let me call it save task itself. For now if I make a change, this component is a dummy component, so I'm manipulating the dummy component based on the node itself that I'm creating. So great, save task entry is also there. And after that, what am I going to do? I'm going to save the task. So I'll need a method here which does the actual thing of saving the task. Alright, great. Let's create the control flow. Connect to the save task entry. Connect this guy to save task. You see how I'm able to choose these things graphically. When I just click the next node, from save task it's going to load tasks. So again I'm going to do the same thing. See, I say connect exit on the owner node, and then I just choose the next node from here, and that gets automatically chosen here in the drop down, or I can choose it in the drop down and that node will get shown to you anyways. So connect, next is fine. Now we need to add the data. So from this add task I'm going to get the task which goes to save task, and then that save task is an entry point, so that is going to convert the data into a server side variable and pass it to save task. Let's do that. What is that data about? That data is of type task. So do we have the task type created? No. Now we need to create the new task type. Now where do I create that task type? That needs to be done in the developers workbench. So far we have been doing all this thing. Let me save this project for now, and let us quickly look at where the components are. The component behind each one of these, you can say base component, And when you say select in developers workbench, it will show you where in developers workbench the component is. See right here. So you can see that there are some components which are under task main. That's a new repository automatically created. So you see, when we started creating those dummy components all got created over here, and they are exactly of the same names as the nodes that created those components. So far so good. So whenever I go to any node and say base component, select in developers workbench, it will show me the base component of that node like this. Alright, great. So as we said, we need to create a new type here. So let me create a new type that is called task. There is no base type for this. A task object. Now what are the members? Let me create a task ID that will uniquely identify it. Typically it's a good idea to create an integer or long kind of ID so that it can be at the database level, serve as the unique ID on the database side. Then there is a name of the task, which is going to be a string. If you want, you can add a description. But even if you don't add a description, what is most important is to add a due date, and that's going to be a date, right? Great. So when I click OK, then it reminds me that there are no implementations that I have created. So if a component does not have an implementation, this will anyway restrict the usability. Should I continue? No, wait. Let me cancel this guy. Let me create an implementation here. So in the bottom portion of this dialog, you will see implementations, and there are no implementations because in front of existing there is nothing. Create new. So it can let me create a new implementation in a technology. Because we are talking about Java application, let me create a Java implementation right here. Alright, a Java implementation is being created. It's an unimplemented implementation. If I just click OK, that unimplemented implementation is going to be created over here. Click OK. Alright, the component is created now, and we can come back to our assemblers workbench. Okay, from here, let me create a transient node between this and this. Transient because it is going from web to the server, and that is going to be an HTTP call, typically an HTTP post request in this case, because it is going to take the complete task with it. Just save this repository so that these components are going to be available to you, okay, just to be on the safe side. Fine. So on to creating a transient node. First click transient, say task tr just to indicate to ourselves that it is a transient node. Type, I'm going to choose yes here because I am going to choose the task type that we newly created. You can find it right here, task main. I'm going to choose the Java implementation of that task, and fine, great. And this is going to get connected as HTTP post, because whenever I submit a form, then typically it is done by HTTP post method as a request parameter and plain. That's how it is going to go. So as you understand, there is no provision for HTTP to pass complex tasks like this. So either you pass it as a JSON, or you just pass multiple task parameters in the request, and then somehow stitch them back in the entry point when they receive. But here you can operate at a high level and say that, hey, I'm passing a task on the HTTP side. So great, let's connect this guy out data to this task transient, create a new argument task, similarly connect the in data to this task transient, create new is fine. I'm going to call it task. Now I'm going to create a data node called task, which is to be outputted by this entry point by converting the data that it received in the transient node. Fine, let me create that. Task of a known type, which is this one. Great, so this task is there, and from the entry point let me output this guy. So out data, connect to task, connect, create new, task is fine, connect in data, task is fine, create new is fine, task is also fine. So now this is connected. Great. This means that we have completed the design, both the control side as well as data side, for the add task side. Let us save this project. Okay, now let's worry about what happens when I complete the task. When I complete the task, I want the task to go away from the list. So basically it should be deleting that task directly. Okay. Again, from the task list, in front of every task, we will have some kind of checkbox. And when you click that, then it will go to the server, and the completing tasks formality will be completed on the server side. So which means that from the task list, I'll need another entry point which takes this new request. So first let me create the entry point. It says complete task entry. I don't have an existing one. URI I'm calling complete task. So from task list, I'm going to connect an exit path to complete task entry. Let me say connect. I already have add task, which is going to add task entry. So I'm going to create a new one here, which says complete task, and let it go to complete task. Whenever you click the checkbox in front of a task, the task ID of that task should be going to the server. So let us represent that by a transient node. Task ID transient, call it transient. What is the type of the task ID? It is a long, as we had kept. So long is fine. HTTP get is fine because only the task ID will be traveling. So again, from this task list, connect out data as the task ID tr, connect, create a new one, say task ID, this is fine, connect in data, task ID is fine. Great. So the task ID is come to the server side now. When we invoke the entry point, from this entry point the control should go to a method which actually goes to the database and marks the task as completed, isn't it? So let's create a method node, mark task completed, and this actually is going to remove that task in our simplest implementation. Removes or deletes the task. Great. From complete, let's connect the exit to mark task completed, and from mark task completed, once it is completed, let us connect it back to load task so that we will see the task list. And this time, because the task is deleted, it will not show that completed task. The only thing that is missing is that this guy needs to send the actual task ID to the mark task completed. So let us create the variable now, task ID. It's a long, it is not transient, so we are good. From here I say complete the out data to this task ID, connect in data to the task ID. Alright, so this completes our flow diagram changes. Now as we know, our X flowchart is created here. All these things you will see as reflected if I just open this nodes again. You will see the newer components created as well. Okay, so the next task before we hand it over to developers is to create the code for create the template codes for each of these tasks, and that still does not require any programming expertise. Let us start doing that. For the save task, you can see that there is an existing implementation called Java implementation at the bottom of the dialog. Let's click that Java button. It's an unimplemented implementation, which is perfect. Go to the implementation side and click the template. Now it says Xsemble Cloud needs implementation for the following nodes, which is the task. Because this is going to be dependent on the task, so I'll need first the implementation of the task node. Let us do that. The same process, task, existing Java implementation, click on the code template button, and now I can see the code template for this task. What I see on the left hand side of the split pane is the generated code template. It is generated based on the definition that I have given. So in this case, this has ID, name, due date, etc. This is all Java code that it has generated. We are not going to do anything with the Java code. We are just going to copy paste this on the right hand side, so that new code is being saved on the right hand side as the task thing. You will see that it has also created a resource dependency, which is fine. It has created a file, and all these things will be automatically saved when we do it. The status in progress is fine. When I'm sure that the component is complete, that's when I'm going to mark it as implemented. Alright. Would you like to mark the component as sealed? A sealed component is something that you cannot modify from outside. When we say outside, it is about outside the developer's workbench. So far you saw that we did the design from the assembler's workbench, and that automatically made some changes to the components. Even we created the components from the assembler's workbench itself. But once we make those components as sealed, we will no more have that facility of modifying it from outside. You can always modify the component from inside the developer's workbench. So what is the purpose of this sealed thing? It is for code reuse. You see, in real life, you will have the same component being used from multiple places, possibly from multiple projects, or even within the same project it could be used in multiple times. So if any of those used nodes try to modify that, then other nodes are going to get broken, and that is not a good situation. So if we make it sealed, then that is a protection for us that this component is not going to be modified from outside. So in this case, the task node is good, so I'm going to mark it sealed. All it results is this checkbox being checked. So I'm going to leave it as sealed. Click OK. Alright, so the task implementation underway. Now let's reattempt this save task. Same process. Take the code on the left side, copy paste it on the right side. See, this is a different code, and you will see that there are helpful comments which will help the developers about already the in argument is defined, exit path is defined, so many things are going to be there. We are not going to worry about it. All we are going to do is press OK and be done with it. So I'm going to do the same thing for all the components now. So let me speed up. I'm marking all of them as sealed as I go along. It is suggesting me to do that. But if I don't want something to be sealed, then I always have the choice of not marking it as sealed. Okay, 4 more to go. This is a code template that is automatically generated for our developer friends, so that they don't have to start from scratch. Typically when we draw UML diagrams, of course there are ways to generate some code out of the UML diagrams, but typically the most likely scenario is that we will be using the diagram and write code from scratch. So in this case, because we are generating this code from Xsemble, that is going to save a lot of their effort. Alright, this is the last one, and I think I'm done. Yes. So this is the end of our design. What we have done is we have drawn the Xflow chart. We also went to the components and we created the code template for each of the components. This is the end of our design activity. Now our developers can take over from this point on to actually add their implementation logic inside this code templates that we just created. Thank you. Thanks for watching.